Dr. Charles Miller. I'm an aerospace engineer at Spaceport America. Now I'd like to demonstrate how the moon goes around the Earth and ask the question, does the moon rotate? And does the moon really have a dark side? So we have our demonstration with our soccer ball representing the Earth and our other moon ball representing the moon to scale. Remember, if we wanted the right distance, they'd be 20 feet away. We have a third element, the sun, represented by this lamp. Now, if we were again at the same scale, we would have that be a globe 72 feet in diameter, 1.5 miles away. For now, we'll pretend that's the sun, and that means the side of the Earth that faces the sun is the daylight side, and the side that faces the camera is the nighttime side. And the same is true of the moon. So what first we're going to do is see if it's possible for the moon to have a permanent dark side. Now, one important thing to remember is an observation we can all make is that the moon always shows the same side to the Earth. When we look up at the moon, we see the shapes that we call the man in the moon. It doesn't change. It's the same for all phases every time the moon goes around the Earth. So what I'm going to do now is show an example of the moon going around the Earth. And this is how it works. If we look at the North Pole, it moves around counterclockwise, and it takes 1 month to go around the Earth. Now, of course, picture the Earth spinning once a day. So we've gone around about almost 29 times in the time that the moon took to go around the Earth. So now let's take a look at which side of the moon faces the sun. So I put a little sticker here, a little I love space sticker, to designate one side of the moon, and we're going to call this the dark side. So what does that mean? That means the dark side is going to have to face away from the sun all the way around the Earth in one orbit. So let's do that, and then pay attention to whether the same side of the moon is facing the Earth at the same time. So as we go around, I love space stickers always facing away from the sun. It's always on the night side. Go around the Earth once in a month. And what did we see? We saw that on part of the orbit, the sticker was away from the Earth, and the Earth saw the side on the opposite side of the sticker. Here, you could see the side of the sticker. So this is not how we see the moon. What we see is one side facing the Earth as it goes around, and to do that, we have to turn the moon around during an orbit, keeping that same side facing the Earth the whole time. So what that means is all of the sides of the moon saw the sun at some time. In this example, if you were on one side of the moon, you would have seen the sun in the sky for 2 weeks, and then it would have been dark for 2 weeks. So a day on the moon is the same time as it takes to go around, or 1 month. So that means there isn't one side that's the dark side of the moon all the time. However, what we can say is there's one side of the moon that is the far side. There's a side that's near to the Earth, the one that we see, and then there's a side that's the far side. It's a side we can't see unless we travel to the moon. Now I'd like to demonstrate the reasons for the phases of the moon. The phases of the moon are caused by the relative position of the Earth and the moon and the sun. And as the moon orbits the Earth, we see different percentages of the daylight side of the moon. And that changes shape over the month, and that's what we call the phases. So for this demonstration, we have our soccer ball here representing the Earth as seen from the direction of the sun. So the camera is in as if it's the sun. We see the lamp there shining on the Earth, and so that's the daylight part of the Earth. We're going to represent the moon by this styrofoam ball, which to scale to the Earth is about right. And remember though, at this scale, the distance between the Earth and the moon should really be 20 feet. Now in this demonstration, we're looking from the direction of the sun, so you're going to see only the daylight side of the moon from the sun's point of view. But remember, from the Earth, we're going to see different parts of this daylight side as it moves around in an orbit in 1 month. So we're going to start here with the moon between the Earth and the sun. And in this position, we don't see any of the daylight side of the moon. We only see the nighttime side of the moon. So we really can't see it, especially when we're looking back at the sun. And so this is the new moon phase. As the moon travels in its orbit, we start to see a little bit of the daylight side of the moon peeking out around the right side. And that is the crescent moon that sets just after sunset. A little further along in the orbit, we can see half the side of the moon that's lit, and we call that the first quarter. Further along in the orbit, we see more of the daylight side of the moon. That is the gibbous phase. And then finally, in this position, 2 weeks after the new moon, we can now see the entire daylight side of the moon from the Earth, and we call that the full moon. And the full moon rises at sunset. Further in the orbit, we now are back to another gibbous phase. A little while later, again we see half the lit side of the moon from the Earth. This is the third quarter. Further along, we now see just a little bit of the daylight side of the moon peeking out on the left side. So that is the crescent rising before sunrise. And then finally, we return back to where the moon is between the Earth and the sun, 1 month after we started, and we have another new moon.